rock
它的那个
我知道啊，这我设的啊。
2楼的。
各位朋友，大家好。很高兴今天能够在这边办这样的一个活动。我是软体自由协会的理事，我叫李世杰伊利亚 ，twitter.com/Ilya， 欢迎大家发我。这样讲蛮喜乐。那从去年开始，我们公司艺联科技以及斯里兰卡一个很著名的救灾相关的基金会叫 Sahana Foundation， 我们开始在关心说，在国际的一个大的救灾的场合，到底我们能够帮上什么忙？就是我们能够去提供一些在救灾的第一现场，到底什么样的一个协助，去让受灾的人能够跟救灾团队有一些沟通。然后非常幸运的，我们在跟那个斯里兰卡团队合作的过程当中 ，Google 的一个 Google 点 org 的工程师建议我们去找一套软体叫 OpenBSC， 那就是今天我们请到Holger 来跟各位分享的这套软体叫电信相关的自由软体。那它其实是在处理电信的领域里面的就是一些基本的功能，但是用自由软体的方式来去解决。那我觉得这是一个蛮特别的机会。那所以我们今天也特别邀请，就是了解 Holger 跟 Harold Wilton， 就是说 OpenBSC 的作者的国内的著名的hacker黄进群 J-Surf 来也做待会就是在我们演讲完之后的一个语谈人。好，那我想待会我就把这个时间就交给这两位。那首先我再让 Jason 来补充介绍一点关于他们的一个这个资讯。
大家好我想这个专案其实这专案蛮有趣的啦。最早的故事是这样最早2006年底的时候，有一个专案叫 OpenMomo， 不知道有没有大家有听过，就是建立一个自由软体为基础的一个手机。好，那这个东西呢做出来遇到一些问题，然后就是这样子，遇到一些问题。但是后来有一个副产品呢，就是说手机做不出来怎么办？来做基地台。那大家觉得，这听起来有点荒谬，对不对？手机都做不来，还要做基地台。但是你要想一下，就是说，其实自由软体应用可以很多啊。你想象一个 case 比方说你在好，我们游艇好了，豪华的游艇呢，基本上它会透过卫星电话去跟来做通讯嘛，所以你可以透过卫星电话，然后拨打，这都是没有问题的。可是问题是，要用什么样的载体其实手机是最好的载体。你在参加一个，就是你在一个渡轮上的时候其实如果你的手机还可以收到简讯，你可以如期收发简讯，就是一个蛮好的事情但是不可能每个人为了收简讯都去拨打卫星电话，这是很荒谬的事情每个人都有随身自己的手机所以如果你有一个自由软体的基地台的话，你就可以做这样的事情，就是你可以比方说后端是由卫星电话输出但是你在渡轮上你就是你还是用 GSM 的手机那它的像素性最好，那你还可以这样可以收发短讯那其实有很大的一个便利性。那刚才讲的救灾其实也是非常非常好的应用其实总之就是说，只要自由软体存在，就可以做很多有趣的事那除了这以外呢，其实后来大家也想到另外一个 case 就是说把那个旧的东西拿出来像这只手机这是摩托罗拉手机那是人保电脑代工的那这里面的东西呢，就是一个很普通的东西但是它里面的 modem 它是用 TI 的 modem， 所以你可以做它有很多 data stream 已经 open 了所以很多黑客呢就开始黑客它做什么呢？把它 modem 的功能把它挖出来，然后把 modem 功能黑客出来之后，你可以做什么呢？你有自由软体的基地台，你有自由软体的手机，那你可以做很多通讯的应用那像网管的话，你可以设定很多很复杂的一个，像你server当地的时候你就通过手机去转发讯息，这种很多应用都可以做出来那所以就期待Holger的分享
谢谢。那我们现在欢迎Holger 飞者来跟我们分享 OpenBSC。
without microphone or should I use it?
听得到吗？就如果不用麦克风，大家听不听得到？
可能麦克风比较。
Microphone is better. 你们希望有中文翻译吗？还是说英文的分享就可以？有。
听不懂都有人提问算这样。
听不懂的时候你们提问好不好？好，那对，好。
Hello again. I would like to talk about free software in GSM, but in general GSM, besides having millions of subscribers, is not very known to us engineers. So I will look into GSM first, some history and explain stuff, and then go to the free software point of view. And if you're all GSM experts or work on GSM mobile stacks, I'm happy to skip this. I don't want to bore you. So yeah, what is GSM? What is the state of free software? And then we can look into the source code or browse or go into the details you find interesting. And to see if you understand my English and my weird German accent, here's a little warm-up shit. So, who of you has used GSM or 3G phones in the last week? Okay, some are too focused on the laptop. Who has used the TCP IP protocol in the last week? Okay. So, who created an IP trace, like in case of a network issue? Who used TCP dump or Wireshark in their life? This is breaking up, but somebody else?
No.
You know these tools? Yes.
Windows we don't talk about it because someone will say Win too dark.
Too dark. So, who did the same for GSM? Who traced his mobile communication with the network? No, none of you? Someone? No? And the final question you can think of during the talk: where's the difference? Why do you know TCP dump and Wireshark but can't trace GSM communication?
I don't know what to do.
You don't know how to do it?
Yeah.
Okay, another explanation would be it just works and you don't need to trace it. You have to, please think about this during the talk. So, this is focused about GSM to give you a rough idea about what GSM is. So, who of you knows what GSM stands for? I think that's a more modern definition, but what is the historic one? Anyone? Oh, yeah, it's a bit French probably. It's like Groupe Spécial Mobile, which is like special group for mobile communication. Because when people decided to build GSM, it was still 1980, before I was born, and you had analog systems for communication. And in the 80s, they decided to build like a digital, European-wide cellular system. So they had like two ambitious goals. One was to make it digital, and the other one was that you can buy a phone in Germany and travel to Spain and it works, and you can make phone calls and can receive them and roaming works. So there were like really two ambitious goals in there, and to make it even harder, they said they want to be done by 1991, which they didn't, but at least they tried. And this, I think this is one of the examples where a multi-nation and multi-company project has actually produced something really working well. And during the process, they created like the ETSI organization in Europe, like it's a standardization body who brings out the GSM specifications, 3GPP, and other mobile communication protocols that you can download for free. It's with GSM, the achievements from my point of view, it's working. It's even one of the first digital systems. There are about like 1,000 documents describing how it works, so a lot of paper to read. But the result of this carefully specified system is that you have a well-structured system with many default components, that can be exchanged. So we have like many vendors that provide specific components that can talk to each other. So it's a lot like the IP world where you can write a TCP/IP stack and it works with other systems. So with GSM you have the same, you have like well-defined elements that you could replace if you start developing code. And this is like a picture from Wikipedia with the rough idea of the GSM network. I assume most people have like this in their pocket. Nowadays probably iPhone or Android systems. And it communicates wirelessly with a base station or base transceiver station. And the base transceiver station has like a link to the BSC. And the BSC connects to the core network with like the MSC and VLR. And from there the message might go to another MSC or to the plain old telephony network. So from here there's like the very different stack in terms of networking protocols. I'm now going to have like a brief look of all the systems involved and their responsibilities and what they communicate with. Is this boring? Do you know this in and out, or should I be faster?
Continue.
So yeah, it's a brief look at the components and figure out what it means. So this is the mobile station. Nowadays it's not so much of a station, but really mobile. And it's like maybe 6 years ago what the modem was with the AT commands. I mean, it's modern chipsets, it's a different communication protocol. But to the outside it provides the AT command set. So, you probably have seen some years ago. And the main purpose for the mobile station is to communicate with the BTS. So it's using the air interface to communicate with the BTS, and over this air interface it's exchanging messages that are terminated on the BSC, but also on the MSC. Too confusing?
No,
No,
continue.
okay.
Yeah. If we have question, we will.
So the base transceiver station, or the BTS, talks the ABIS protocol with the BSC, and it obviously needs to implement the air interface to communicate with the mobile station. And yeah, in general, the responsibility for the BTS is to provide the air interface to make the radio communication work and to send the broadcast messages so a mobile station can find the network.
Why is it called UN? Why is it named UN?
I have no idea. Can I use my Wikipedia joker? No, it's just kind of slow. It got some title. Looks like I can't use my Wikipedia joker.
The U interface is the ISDN interface.
Okay, and M for mobile.
Yeah.
Okay. So, do you know ISDN or?
Yeah, I know ISDN.
So.
Because I have developed a video conference device.
Okay.
Yeah.
So the U interface includes LAPD. Okay.
Thank you.
I've learned something too. Thank you. So the BSC in general communicates to the MSC. using like the SIGTRAN stack with maybe SETP and then MUA or M3UA and then SECP inside of that. It's just to make people confused. They didn't want, well, when they started doing it, IP wasn't that deployed, so they have their own protocol stack coming from a different world, but at first it looks very confusing with all the different protocols they decided to implement. But once you start dealing with it, it gets okay. So a lot of buzzwords, but it's not that complicated. It's really not that complicated. And to the other side, the BSC talks with the BTS on the ABIS interface. And the responsibility of a BSC is to allocate the radio resources. So it gets a request from the BTS that a phone wants to have a channel, and the BSC can decide which channel it gets from its available channels. It's handling encryption in terms of deciding which encryption algorithm to use or not to use. And the mobile switching center itself is quite easy. So the switching center stands between like the GSM world and the classic telephony SS7 world. So it needs to convert from protocols like ISUP, ISDN user part for call control. It needs to convert these messages into the equivalent for GSM 0408 call control messages. Or if it needs to communicate with another system, it needs to forward messages to this system. So the MSC is really mostly translating messages from one protocol into another. The magic for GSM and roaming happens in the HLR and VLR. Which is the HLR is for home location register. It includes, or in the HLR, for every MS-ISDN, it has the current IMSI number stored and your secret key they use for authentication. And the HLR of a system can be asked where you are currently, like what is the VLR that you're associated with. The visiting or visitor location register is the one where your phone is currently registered. So if somebody wants to send you an SMS, he knows your phone number. He goes to your HLR and asks, tell me where is this subscriber, and then the HLR returns, go to this VLR. And then you go to the VLR and you ask for a temporary phone number to send an SMS to the subscriber or to call him. Okay. This is like a really fast and rough introduction to GSM. And every system itself is complex, but they have like a really well-defined interface to talk to the other interface. So there's a very well-specified protocol how HLR communicates with the rest of the world. It's like a document with I think 10,000 pages and A's and one definitions and sequence diagrams, so it's very well specified. Just a lot to do. And now I would like to get to the part of the state of free software in terms of GSM implementation. So, but until like 2006 or 2007, it looked really bad. There was not even any library that could send AT commands to a phone without crashing. So there was no open source system for the tough part in the network of BTS, BSC, that even just using GSM in open source was like a horrible experience.
The Ericsson have released the AT commander for the mobile phone 10 years ago.
Yeah.
So why you say the barely working with the AT commander preface? They already released the AT command for the mobile phone.
Yes, the AT commands are even fully specified in GSM.
Maybe not for GSM, their own command. the special command.
No. My point was like when we worked at OpenMoko to build a phone, there was no library that could make a call for us. We had to start developing a daemon that sends AT commands over the serial line. So there are many applications that like Gamu, which can do SMS on a Nokia phone, has some AT command tools, but there was not really a working library that you could just use to place a phone call. So for something as simple as sending like ATD and the phone number, there was no library or no tool support to do it. Which is quite embarrassing. Like 2006, simple AT commands over serial was not there. And if you look at this GSM network, significant, it should not be on the mobile station side, but more on the other parts. So starting from 2007, something started to change. So I think Burning Man 2009 or 8, like David Birch's showcased OpenBTS, which was like a software-defined radio platform. And Harald was able to purchase a used Siemens GS11 on eBay. So at this time, for some magic reason, more people got involved in open source GSM, and you were able to find used equipment on eBay for affordable prices.
But then can you talk about more about the open BTS, because it is very, we don't have the equipment in Taiwan.
I'm getting to it in a second.
Oh, okay.
And afterwards, after OpenBSC, we started playing on GSM on the mobile station. Like not AT command side, but more really signal handling on the phone itself. And we're getting closer into the network as well. So for project, I have started implementing STP, which is another standard component in a core GSM network as open source solution. And we started to write MSC, VLR, HLR code as well. So there should be like, within a year or two, there should be a complete stack for GSM core networks in open source. Okay. So OpenBTS, I'm not involved with this project, so I can just tell you what I know from it. So the main developer is David Birches. He's like an US citizen, and he worked in signal intelligence before, and he used the USRP1, which is like the universal software radio peripheral, to implement GSM, or the GSM BTS, and some other code with it. It works using the GNU Radio framework. And in contrast to like a specified BTS, he handles call control SMS himself, but he's forwarding everything to SIP. So it's not a GSM component you can just put in a network, but it's implementing the GSM protocol on the air. But from this point of view, it's, after this, it's different to normal GSM because everything goes to SIP.
Uh, 软体无线电。它就是说，他的意思是说，它这个 OpenBTS 是所谓软体的无线基地台，那就是用的硬体是 USRP 这块无线射频的模组，然后 USRP 的无线射频模组就是说，你可以变成一个基地台去，就是说去做一个基地台，然后拿来translate Chinese because maybe they
所以它跟实体的
It's simplified. I'm sorry, it's
你
simplified.
说实体的什么？
handset
它的 handset 是不是？
它没有射频的。
它射频它是这样子的，它的条变是走它自己的 FPGA 去做运算，或是电脑的X86去帮忙运算。它的条变 ADDA 全部都是这样子去做的。那它的条变就是基频这个转换，这些全部都是靠软体的演算法去处理。那你只要管好什么就是射频，那射频再去，它等于就是一块板子再接一个射频模组，这样搭配起来， 就可以做一个全功能的一个射频的一个发射跟接收平台，那就是这样的硬体。对，那这个是没有接上射频模组，这是主板。台湾有几所学校有买。
你平常到底在干什么？
啊？
你平常都每次到底在干什么？是古董吧？
啊，这新的，这新的，这新的。
上面可以接4块。
对，它有4块射频模组。
So David Burgess wrote GSM for this hardware, and with something called front ends to handle like radio frequencies in a specific frequency that you can plug on these slots. He implemented OpenBTS using the GNU Radio framework, or parts of the GNU Radio framework. The limitations from what I know is the BTS only has 1 TRX, so your cell size is always limited with the open source code, and there's no GPRS or Edge implementation. Do you have any specific question for OpenBTS that I might be able to answer? Or no? Okay. Then I would go to the OpenBSC project. So Harold was able to buy a Siemens ES11 from eBay, and then it's like a 25 kilo heavy device called MicroBTS. And then it was sitting in the living room for half a year unused, because the difficulty is it's not like a modern computer. You put in Ethernet, it gets an IP, it boots up, and then it just works, but it's using like ISDN E1 and a protocol on there. You need to know the time-slot configuration, so it took a while to figure out how to power it up and how to make it do stuff. And nowadays we have a more modular equipment like the IP-Access Nano BTS. So it's nano is smaller than micro, and in this case the equipment only weighs like 3.5 kilo. So it's portable, and on top of this it's not using ISDN anymore, but has IP support. So it's a really portable device that can be used as a GSM BTS. And some of my work in the last year was turning our code into a real BSC. So it's just, before we just toyed around running a GSM network in one executable with not implementing like the connection to an MSC, but handling everything ourselves. And since like last year we are able to connect into a network like as a classic BSC component. After we figured out how to use a BTS and have a BSC, we wanted to understand what it takes to run on a baseband processor. So the general hardware design from all the hardware is you have a baseband processor, mostly like an ARM7, and a specialized DSP. Then we found, like on SourceForge, there was the company Purple Labs from France. They had TSM30 source code for their phone, which included the baseband code. So we could figure out how they drive the DSP with source code available from SourceForge. And it turns out that they support a generic chipset family from TI called the Calypso. So we wanted to do our own hardware design using the TI Calypso, but then we found really cheap phones like the Motorola C123, which I heard has been produced by Compal. And after looking into the firmware, we saw like support from the bootloader to load code via the serial console. So apparently many phones export the serial console over the headset. So you can just buy another cable on like markets that has USB to head jack sets that allow you to talk to the bootloader. And after after we were able to load our code and talk to the DSP, we started implementing a mobile station support on the phone. Actually, it's a system that implements some parts on the baseband processor and also still has many parts on the host system, which kind of looks like this. So if I try to restart my phone, it starts loading code over serial and then powered up. And the next part is to start an application that talks to the phone, to the baseband. Which is now like it's a Cellog application which makes a frequency scan and then tries to connect to networks. Which in Wireshark then shows us the received frames from the network. So just searching for not working at all. Let's try again. No, it doesn't like me anymore. I will try to boot it again. So. So it's going through all frequencies and it dumps the received frames at just the control channel. And it sees other messages. So we have like a device to look at the networks, find the networks,